About 70% of Earth's surface is covered with water, and most of that, about 97%, is in the oceans. That's right, all the glaciers, ice caps, aquifers, groundwater, rivers, lakes, and streams only make up 3% of Earth's surface water. But the surface of Earth was not always so wet. In fact, Earth was a very dry place for some time after its formation. It's believed that Earth is about 4.5 billion years old, and that our oceans are only about 3.8 billion years old. There are two main theories describing how the oceans on Earth formed. First, it's theorized that Earth was formed with water, and that this water came from the inside out. The other theory is that Earth did not contain any water when it was formed, and it was instead brought here by other sources as they hit the young planet. We don't know for sure which is true, or if one is truer than the other. Many scientists favor the first theory as the major source of Earth's ocean water, but most believe it's some combination of the two. For this lesson, we'll discuss the formation of the oceans using both theories so you can see how each method could have contributed to the process. Our solar system originally started as a large swirling cloud of various gases, ice, and dust particles. Eventually, these components aggregated together in different ways to form the planets that make up what is now our solar system. Early Earth was a very inhospitable place. It's believed to have been formed from meteorites, but it didn't start out with the neatly divided layers we have today: the inner core, the outer core, the mantle, and the crust. As this differentiation, or geological separation of layers by density, was occurring, there was also much releasing of gases onto Earth's surface through volcanic activity, a process called outgassing. And while all of this was going on, Earth was also being bombarded with materials from outer space, such as comets. These space materials also brought gases to Earth, and eventually these gases, as well as those from outgassing, formed our early atmosphere. Earth's early atmosphere was HOT. It trapped heat on Earth like a greenhouse, so that temperatures on the surface were possibly as high as 400 degrees Celsius. While water did exist in the atmosphere in a gaseous state, it was way too hot for any liquid water. It would have simply boiled in that extreme heat, instantly turning to gas and rising into the sky. Throughout the next several million years, the atmosphere and surface cooled. Temperatures came down to below 100 degrees Celsius, which allowed water to remain in liquid form. Much of the water vapor in the atmosphere fell to Earth and filled shallow basins in the ground that eventually became the large, deep oceans we have today. As we have seen with other planets, just because there is surface water at one time doesn't mean it will stay there. For example, it's likely that both Venus and Mars once had liquid water on their surfaces, but there's no evidence that it still exists on either planet. Retaining water on the surface of a planet is tied to several different factors. First, Earth is in a sweet spot in the solar system. This is because it's just close enough to the sun to stay warm, but far enough away to stay relatively cool. It's also a good size. Earth is large enough that its gravity holds the atmosphere in place, protecting Earth's surface from both receiving and losing too much heat from solar radiation. The composition of Earth is also an important element. The outer planets in the solar system, Jupiter, Saturn, Uranus, and Neptune, are comprised mainly of gas. In contrast, the planets that are closest to the Sun, Mercury, Venus, Earth, and Mars, are mainly rock and heavy metal. It would be difficult for liquid water to form on the gas planets because they do not have solid surfaces like Earth and the other rocky planets do. Below Earth's surface, though, is the mantle, which is where most of Earth's water is believed to exist. More than two-thirds of the crust is covered in water, but Earth's crust is on par with an apple's skin. It makes up only a very small fraction of the whole. The mantle, however, makes up more than 80% of Earth's volume, and it's estimated to contain 3 to 6 times as much water as all of the oceans. Because Earth is just right in so many ways, it's often called the Goldilocks planet. The right size, the right composition, the right place, there's certainly nowhere else I'd rather be. Earth formed several billion years ago, but the oceans didn't form until much later. This is because initially Earth was much too hot for liquid water to form, and it instead existed as a gas. However, once Earth cooled down enough, some of this gas came down to the surface as water and filled shallow basins in the crust that are today deep and vast oceans. We don't know for sure how water came to be on Earth. One theory is that the materials that formed Earth contained water, and through outgassing, or the releasing of gases onto Earth's surface through volcanic activity, water came from the interior outward. Another theory is that Earth formed without water, and that bodies that collided with early Earth brought water to the planet from the outside. It's likely that water came from both sources, though many scientists believe the first theory is where the majority of Earth's water initially came from. Having liquid surface water is one thing, but keeping it is quite another. The location of Earth in the solar system, its composition, and its size all make Earth a very special place because it prevents the loss of our water through evaporation or freezing. And because liquid water supports biological life, I'm sure you'll agree that this planet we live on really is just right.